Welcome to the talk on JUnit 5, Evolution and Innovation. My name is Sam Brannen. A little bit about myself. I'm a principal software engineer at Pivotal since a few months now. I've been a Java developer for over 20 years, and I've been a core committer for the Spring framework since 2007, when I originally rewrote the entire testing framework based on annotations, like JUnit 4, TestNG, and stuff like that, and I continue that to this day. I'm also a core committer for JUnit 5 since October 2015, so since JUnit 5 started up. So the agenda today, first I want to talk just a bit about JUnit 5, just to make sure we're all on the same page in case you haven't used it before or haven't seen it. Then I'll talk a bit about JUnit Jupiter, what's new, what's coming, what's on the horizon, and then I'll talk very briefly about using Spring and JUnit Jupiter and Spring Boot. And then at the end, if we have time, some Q&A, or I could potentially demonstrate some things if people have questions about specific features. So first up, I'd like to see a show of hands. Please raise your hand if you, who writes tests? Yeah? Who writes unit tests? Yeah, integration tests? So a lot of people end-to-end tests? Fewer and fewer, okay. Who uses a framework called JUnit for testing? Okay, anyone use anything else? Yeah, TestNG? Few people, Spock? Few of those, okay. So for JUnit, who's on JUnit 4.12? Probably most people, yeah. And who's on JUnit 5 already? Anyone? Good number of people, okay, cool. All right, so JUnit 5, what is it? Here's the big picture, as we'd like to say. So we have in the upper left, or in the middle, let's start in the middle, we have the platform. That's the new JUnit platform. And then you can have different engines that are connecting to that and running on that. So we have Jupiter in the middle, which is the new stuff. Vintage is the old stuff, JUnit 4, JUnit 3. And then third parties can write their own test engines that run on this. The thing that's great about this is that the IDEs and the build tools you see down at the bottom, they focus just on the platform. They don't have a specific knowledge about the engines, which means that anyone in the world can write their own engines, and some people have done that, as I'll show you later on. So it's very different from what JUnit 4 was. JUnit 4 was just one jar, and JUnit 5 is like, I forgot, maybe 14 jars now, but it grows over time. So JUnit 5 is actually a combination of three things. It's the platform, Jupiter, and Vintage. And again, the platform is this foundation for launching testing frameworks on the JVM in general. They don't even have to be Java-based, right? So we have this launcher API that the build tools use, and the test engine API that you can implement. And there's a console launcher to run it from the console if you want. Jupiter, if someone says I'm writing tests in JUnit 5, they probably mean that they're writing tests in JUnit Jupiter, because that's the new programming model and extension model for JUnit 5. And then Vintage, this is this engine for running your JUnit 3 tests and JUnit 4 tests, and your old Spock tests would also run on as well. The Spock team is actually writing a test engine to run on the new JUnit platform. So the first part is revolutionary. That never really existed before in terms of JUnit, or actually on the JVM having this kind of globally usable testing framework. And then evolutionary, right? So there was JUnit 4, and now there's JUnit Jupiter. JUnit Jupiter kind of builds on the experiences, the things we learned from JUnit 4, and goes beyond that. And then necessary, obviously people want to be able to write or run their old tests at the same time as their new tests within their IDE, within their build tools, and that's why the Vintage engine exists. So it's just an adapter layer from the platform to JUnit 4 and JUnit 3. So in terms of test engines, if you check out this web page, this third-party extensions page, you'll see that people have implemented their own. These are just some examples: Spec, CSpec, Cucumber, Joules, and JQuick for property-based testing. In terms of Java versions, this is a tweet I did a while back. How about a bit of poetry for JUnit 5 JDK compatibility? Works great on JD8. That's actually the baseline. We require Java 8 or higher. Also works fine on JDK 9. So we've had, originally we had automatic module names, but we added module descriptors in 5.5. So your module info is in there. And we have also support for scanning the class path, the module path to find your tests, in addition to scanning the class path to find your tests. We're scanning JDK 10, on 11, EA was at that time. We see in the bottom right that we actually have a build matrix. So we test against JDK 11, 12, 13, and 14. Well, at least we're working on that. So we're actually making sure that we're staying up to date on the new JDK release cadence. In terms of IDEs and build tools, scene looks really good now, late 2019. So IntelliJ was the first. They had support in 2016. Eclipse came after that, 4.7.1a. VS Code has support since March last year. NetBeans has support since NetBeans 10.0. In terms of the build, so Gradle's had official support in the test task with the Use JUnit platform action you can use there since Gradle 4.6. Maven since Surefire 2.22.0, and even Ant has built-in support with the JUnit launcher since Ant 1.10, and they actually beat the Maven team, if you can believe that. So for examples of that, how to set that up in your build, you can see the user guide or some of the sample apps, or if you're here, you might be interested in just going to start.spring.io. So the latest versions of Spring Boot will actually use JUnit Jupiter as the default instead of JUnit 4, in case you're not familiar with that. So I think it's a good thing, but you might be shocked. Just be prepared for that. In terms of versions, so we released 5.0 after about 2 years of development back in late 2017. We've had a couple of several releases in between, 5.1, 2, 3, 4, 5, etc. So 5 being the most recent, and 5.5.2 is what you should be on if you want the latest and greatest, including bug fixes. So that was just last month, right? So Jupiter is the 5th planet from the sun in our solar system, as you might be aware, right? So that's why it's JUnit 5. We didn't call it JUnit 5 because if we have version 6, it would be silly to call it JUnit 5 version 6. So JUnit Jupiter is this new thing. In a nutshell, it's the new programming model and extension model in JUnit 5 to kind of replace JUnit 4. The program model, that's how you write your tests, annotations you use, assertions you use, assumptions, things like that. And the extension model, that's how you and third parties can extend the framework to add additional functionality. So frameworks like Spring, Mockito, AssertJ, Selenium, etc. Now you also get a more powerful programming model than what you had in JUnit 4. So some things you can do now that you couldn't do before. Visibility is different. You don't have to have everything public, right? So you can have, as long as things aren't private, they'll be found by JUnit Jupiter. You can have custom display names with an @display name annotation. You can have spaces, special characters, and even emoji if you're into that kind of thing. There's also DisplayNameGenerator. We'll talk about it a bit later on, so you can have custom display name generation. Oops, I went a bit fast. Tagging. So there were categories that were experimental in JUnit 4. We have official support for tags in JUnit 5 on the platform in general, and also in Jupiter. And we have a tag expression language, so it's very powerful. You can say, I want things tagged with this and this, or this, but not this, and things like that. Now the basics, just to give you an idea of what it looks like. Here we have a test class. As you see here, it doesn't have to be public. By default, the name would be calculator tests, but you can give it something custom like this, display name calculator unit tests. And then for your test methods, we have the test annotation, like with JUnit 4. Here, another custom display name with a special character, could also be an emoji. Also doesn't have to be public. And one thing to note, if you're using the assertions from JUnit Jupiter, the message now comes last, so that might throw you off. So here we have the expected and the actual, and then the last part there is the message if it fails, and that can be a lambda expression, right? So we're based on Java 8, so this is basically a string supplier, and if that build takes time to build up, and you want your test suite to run as fast as possible, you can use lambda expressions for those messages. Then they only get evaluated if the assertion fails. Another thing, since we're on Java 8, we don't have this @expected exception annotation or expected exception rule like you have with JUnit 4. Instead, we like to do that programmatically. In our own assertions class, we have an assert throws method that tells you, provide the type you expect to be thrown, and then you provide a method reference or lambda expression. Here we're saying that dividing by 0 should throw an arithmetic exception. We can get access to that by storing it here in an exception, and then assert equals that's the message in the exception. And other frameworks have something similar, like if you use AssertJ, there's also support like this for this programmatic exception checking. We also have support for programmatic timeouts. So one thing you'll notice in JUnit Jupiter, the test annotation is just plain and simple. It doesn't have any attributes like the expected or timeout, anything like that. So you have the first example, assert timeout of milliseconds, 1000, so that's a duration. And then the lambda expression or method reference that we're supplying there. This would be blocking, and it would wait on it to end. And if it never ended, then it would just run indefinitely. So if that's not what you want, we have another option to assert timeout preemptively, and that will start it in another thread and then kill it off early if the timeout is exceeded. One thing to keep in mind about that, if you're using something like Spring and transactions, test managed transactions, those are tied to the current thread with a thread local. So if this thing is spawned off in a different thread, that means that your Spring test transactions would not be visible to the code executed in this Lambda. But as I'll hopefully mention later on, with the new @timeout support and global declarative timeouts, the Spring transactions do actually work because the preemptive part is implemented differently than it is here. So we also have even more power and expressiveness. So we have meta annotation support. That means you can combine annotations. You can have composed annotations with JUnit annotations, or you can also combine them with things like Spring annotations, which makes it very powerful. And Spring actually builds on that. Spring Boot builds on that as well. Conditional test execution. So in JUnit 4 you had @ignore. That was it. And we have a lot more support for different kinds of conditions for your tests in JUnit Jupiter, and you can write your own. Dependency injection, something we also have for your test class constructors and various methods. We've already seen some Lambda expression support. Since we're on Java 8, you can have interface default methods. So you can write test methods and before each methods and stuff like that in an interface, make them default methods, and then you can just implement those. And then I call this testing traits. So you can have various testing traits grouped by interface and then implement different ones. And it makes it kind of like multiple inheritance for your tests if you need that. You might need that for something like a TCK. Something else we have, some people have written some nested runners in JUnit 4. We have built-in support in JUnit Jupiter with the @nested annotation. So you put that on an inner class, and then you can have shared state from the outer instances and things like that. We also have support for repeated tests, parameterized tests, and test factories. Test factories are actually very dynamic. You can have dynamic levels of dynamic containers and dynamic tests, all based on Lambda expressions and method references. And the last part, a lot of people might not realize this, in JUnit 4 you always got a new test instance for every test method. So your test class always got newly instantiated. TestNG did the exact opposite. And for JUnit Jupiter, we decided to give you the choice. So you can pick, by default, it's the old way with JUnit 4, one test instance per test method. But you can switch that to test instance per class, and then you can have kind of shared state across your test methods. If you need that for integration testing, probably not a good idea for pure unit testing. So I'd like to also focus on extensibility of the new framework here. We have a brand new extension model. We have an extension interface, which is maybe not too exciting because it's just a marker interface. But all the extensions reside in the org JUnit Jupiter API extension package. Another thing to notice, the packages have changed, right? So it's not org.junit like it was in JUnit 4. If you're using stuff from Jupiter, make sure you get it out of the Jupiter API package for the things like the annotations and the extension package for the extensions. So one nice thing is you can implement as many of these interfaces as you like in one concrete implementation, right? So with JUnit 4 you had like a class rule or a method rule, but you couldn't combine stuff. And the way you register these, so in JUnit 4 you had @runWith, now we have @extendWith. You can register multiple of these. You can register them on interface, on the class, or at the method level if you like. You can also do that as a meta annotation. Another thing we have that's somewhat similar to the rule support in JUnit 4, we have this @register extension, and that allows you to programmatically register an extension from a field or a static field if you like. So, whirlwind overview of all of these. So in terms of lifecycle callbacks, we have new annotations. We don't have before class and before. We have before all, after all, before each, after each annotations. And for each of those, we have extensions that can wrap around those. So first up, we have the before all callback. And then we have a matching after all, one for around before each and after each. And then we have another level right around the execution of the actual test method itself. And each of these, all these extensions wrap. So the before eaches go from top down, and the after eaches go from bottom up in terms of the execution order. Exception handling, we also have that, but it's baked in, so in JUnit 4 you had to kind of do it on your own with try-catch blocks. For the actual execution of your test, we have the test execution exception handler. That applies to things like your test method and test factory methods, or repeated tests and things like that. Then we also have a new one since 5.5, so since a month now. It's a long name, Lifecycle Method Execution Exception Handler, and this is around all of those lifecycle methods. So around all these methods I was talking about before, before all, after all, etc. And you can combine, you can implement both of those if you want to. In terms of dependency injection, we have test instance factory, so an extension can actually be in charge of instantiating the test instance if it needs to. We have a test instance post processor, which is kind of like a bean post processor, if you're familiar with Spring, and that allows you to perform things like setter injection or field injection, and that's actually what Spring implements to perform dependency injection. Now there's another one, parameter resolver. That's a generic idea for a parameter for either constructors or methods. And extensions can perform injection. Spring does that as well. A few other ones. This execution condition, as I was talking about before, we have @disabled instead of @ignore in JUnit Jupiter. We have some other built-in ones, so you can say test is enabled on this OS, like Mac or Windows, or disabled on a JRE or enabled on a particular JRE, like Java 8, Java 9, and you can implement your own. So it's very powerful. Another one is the newer one is Invocationinterceptor. Probably won't be used by that many people, rather low level, but we'll take a look at an example in a bit. Test Watcher is also new, so there's Test Watcher in JUnit 4, and we have something that's analogous to that since JUnit Jupiter 5.4. And the last one, also a mouthful, Test Template Invocation Context Provider. So @test template is a different kind of way to parameterize tests in different ways. We have different invocations, and the repeated tests and that parameterized tests are actually based on that functionality. But you could also write your own. So all these other ones, these extensions, they're applied while the tests are executing. We do, however, have two that are executed during the discovery phase. So one thing that's different about kind of JUnit 4 and JUnit Jupiter, in JUnit 5, there's a discovery phase. So all the test extensions go out and find the tests by scanning the class path or looking at certain packages and stuff like that. And that's when things like the names are determined, the display names, and the order of the tests. So first up we have the DisplayNameGenerator since JUnit Jupiter 5.4, and we have a MethodOrderer since 5.4 as well that allows you to change the order in which the test methods are executed. So by default, the test methods will be executed in a deterministic order. I won't tell you the algorithm, but it's in there. That's just to make sure you have repeatable builds, but you can change the order if you like, and we'll look at those in more detail. So first up, this new Invocationinterceptor that allows you to intercept the invocation of the test constructor or various methods. So like these before all methods, after all, those kind of methods for Lifecycle, also the test methods, test factory, and test template methods. So in addition, individual invocations of these dynamic tests from that @testFactory method. So why would you want to do that? One example is to be able to execute code in a separate thread. For example, you might want to do that if you have swing code and you need to execute that in the event dispatch thread. Test Watcher. So a test watcher, as the name implies, is supposed to just watch the test. It's not allowed to actually influence the test. If it throws an exception, it just gets swallowed and logged because you're not allowed to change anything. But basically you can process the results of the test execution. You can log stuff, have your own kind of reporting if you want, and you can do some kind of tricky things as we might look at later on. So this is supported for test methods and these test template methods like the repeated test, parameterized test. And various events are fired. So if a test was disabled or aborted mid-flight, so aborted means it was already started, but a certain type of aborted exception was thrown in between and aborted mid-flight, whether or not it was successful or it failed, and you can, react to those events. So again, maybe custom logging, maybe conditional execution of subsequent tests. That would be a more advanced use case. This is DisplayNameGenerator. So by default, it's just going to take the technical name of the method or of the test class, or it's going to look at, we're going to look at this display name annotation, but you can also implement this SPI to generate your own custom display names for classes and methods. And you configure that with the display name generation annotation pointing to your implementation or the one you want to use, or you can use one of the built-in ones. So the standard one is what I just mentioned. You would only need to reference that if you wanted to override some other custom configuration. There's one that's called replace underscores, and surprisingly, or not so surprisingly, it replaces underscores. So if you'd like to write your tested method names without camel case with underscores, you'll just replace all those with spaces so it looks like a little sentence in the end. And there's been some talk about an indicative sentences one. I have an example of that. Another thing that's kind of been discussed is having camel case support, where you split the words or the method names based on the camel casing and make sentences out of it like that. But you could come up with anything on your own. So this method orderer, That's an API for controlling the test method execution order, configured with an @test method order annotation. You can implement your own, right? It's got an API here, or you can use one of the built-in ones, and we have a few that are rather popular. So alphanumeric just does it sorted alphanumerically based on the names of the methods, and optionally based on the parameter list if the methods have the same name, if they're overrides or overloads. Order annotation, we have an @order annotation as well, so you can explicitly specify that numerically, like order 1, 2, 3, 4, 5, if you want to be very explicit. And we have one random, right? So it's pseudo-random ordering if you want to verify that you really don't have any kind of dependencies or interactions between your tests, right, in your unit tests. That could be an option as well. So some people like to change it to random for the entire test suite. That's also possible. So you can set a default method order for your entire test suite via a properties file if you'd like. So what's new since last year, basically? In 5.4, the old JUnit platform Surefire provider is gone, right? Because we have the built-in support in Maven Surefire. There's a new JUnit Jupiter dependency aggregating artifact, as we call it. It's kind of like a starter POM from Spring Boot, right? So if you want to use all the parts of JUnit Jupiter, you can just depend on this JUnit Jupiter artifact in Maven instead of the various different parts. If you're interested in generating your own reports, we have our console launcher generates XML reports using the de facto standard JUnit 4 reporting format, and we made that public since some people requested that. If you're writing your own test engines or extensions, sometimes it's nice to test the tests. Normal people don't do that. I do that rather often because I write testing frameworks. But if you want to test the tests, we have a new test kit that allows you to launch a test engine and select classes to run and then verify the results, like how many things are skipped, what kind of exceptions are thrown and stuff like that. So that's there if you need that. For parameterized tests, we always add in, seems every release, new attributes, new ways to configure different things. So we have new null source and empty sources for those. And we also have @tempter support. So there was a temporary directory support in JUnit 4 with a rule, and we now have annotation-based support in JUnit Jupiter. Also mentioned that before. Ordering, I said you could order the test methods. You can also order the extensions registered via fields, via register extension with the @order annotation if you need to control the order for that. Test watch, we got that one. There's some new support in the extension context for accessing outer test instances for nested test classes. Improved support for, so we do have some migration support for JUnit 4. I didn't mention that before, but we have improved support for, so you can continue to use @ignore annotation and some of the assumptions from JUnit 4 if you so desire, but that's in a separate migration support artifact. Yes, and improved diagnostics and error reporting, which is always good to be improving on. So here's an example with @tempter. We've got a standard test method, void write items, and then as a parameter to this, right, we just declare @tempter. You can specify a path type or a file type, whatever suits your fancy, and then you'll get a new one for this test method, and then whatever is created in that directory will be cleaned up after this test method is executed. So here we have creating a test.txt file, writing to that with this custom list writer we have, and this is just asserting here at the end that the file contains those contents. And again, that directory, that text file would be deleted after this test executes. You can also have a tempter injected as a field. If you want to have it at a field level, you can have it as a static field, and then you could have it higher up and visible to more of your tests and have a shared temporary directory. So, DisplayNameGenerator, I'll show you a demo of that. Here we have, so here we have a test class, and we have this this nested we're seeing here. Oh, that's not good. What if I do that? And then do that? Yes, okay, and that's probably really small, huh? Is it better? Good, all right. So we've got a test class here. It's got some nested test classes in it. These are not static, right? So these are inner classes. And we see this replace underscores. So what do we expect, right? We expect these underscores to replace with spaces. So if I just run this one, we can check that out, see what it looks like. There, we see the, people see that? Yep, a little bit. So we see the underscores got replaced with spaces. And then there's another example in there where my colleague wrote a custom indicative sentences DisplayNameGenerator. So these things are going to be concatenated together. So if we ran that, we should see that we end up getting kind of like sentences. A year is a leap year, a year is a leap year if it is one of the following years, year 26, etc. So you have, you can have kind of like BDD style custom display name generation if you so desire. And if we run all those tests together, just to show you the nested test support, what that ends up looking like in your reports, we expand all. We see we have, so this was the first nested test class and this was the second one, and you can have multiple levels of nesting if that makes sense for your use cases. This is something that wasn't really an option in JUnit 4, and a lot of people actually like it. They kind of like the BDD style. I do use it from time to time as well in my own project. So, what was the next one? Oh, test methods and test watcher, okay. So for ordering test methods, oops. Here I have a class, some tests, cat, aardvark, and bat. Yes, there are ABC, that's intentional. So what happens if I just run it without any kind of test method ordering? It'll be deterministic. It's bat, cat, aardvark, and if I run it again, it should definitely be the same, because I mentioned it's deterministic, right? But what if I wanted to do it alphanumerically? What's it going to be? ABC, right? So there we got aardvark, bat, cat. If we wanted to switch it up and go to based on the order annotation, then we're going to expect, I got this 1, 2, 3, so it should be cat, aardvark, bat, right? There we go. And then randomly, well, random is random. Can't tell you what it's going to say. Did it pick the wrong one? Didn't pick it. That looks like a good one. Okay. So we've got ACB, CBA, etc., right? So that's just random there. Yes?
Can you just keep them in the order they were in the file without numbering?
That is a very good question. So the question is, can you keep them in the source code declaration order? And the answer is you could do it on your own. There's an open pull request to do that. The pull request, we're still analyzing it. The best way to do that would be to implement one of these method orders on your own, and then use something like the ASM library to read the bytecode, and then read the method table that tells you the line items. So if you, the source code line numbers. So if you compile with debug symbols and the line numbers in there, you can look up a table with ASM and you could sort them based on that. So yes, it is possible, but we don't support it out of the box yet. All right, test watcher. So this one's a bit more advanced. Someone asked me if I have these nested test classes, and if there's a failure in the outer instance, I don't want to run any of the tests in the inner instance in the nested test class. And I said, yes, you can do that. You have to write some custom code. So I came up with an annotation, skip on failures in enclosing class, right? Don't run this one if there are failures in the closing one. And where do I have that in place? Running, let's see. I have an example running. So I've got an outer test class, and I got some tests. This one's going to fail, and then I'm saying I have two nested test classes. This one should still run, but this one shouldn't run if there were failures in the enclosing class. So I've got this annotation to kind of denote that here, but I have to somehow track the things that have failed in enclosing classes. So to do that, at the outer level, I registered my custom extension, skip on failures in enclosing class extension. And that implements two interfaces. So it implements this test watcher, because that's the only way to reliably know if something failed or passed or got skipped. And then the execution condition, this is this thing where I said you can dynamically decide whether or not tests get run, whether or not they get executed. So let's just see that thing in action first and see if it actually does what it says. So I run the tests, and we see expand all. Right, so we see the outer one had some failures, the inner one, they still ran, but then we see these marks here, right, these little grayed out. That means these things got aborted, they got skipped, they didn't get run at all. And how does that actually work? So if we go look at the extension, we see that for the test watcher part, we're tracking things that were failed, and then we're just putting them in the store. So you have somewhere to store information between invocations of your extensions. And here I have a little method that's doing it in the root context. I won't go into detail, but basically it's just putting a little bucket for me to store stuff in, and I'm storing stuff in the class name saying true, and that just means if this is in there, that means that there was a failure in that class. And now for execution condition, that's going to get applied for each of the nested test classes. I check out the test class. I see is the current one an inner class, like a nested test class? And then I make sure, is it annotated with this new annotation that I created, this marker annotation? And then if it is, then I get the enclosing class. And then I check in the store if that enclosing class had a Boolean value stored in there with true. And I default it to false by default. So if the thing had a failure, then what I can do is I can say the current class is disabled, and otherwise it's enabled, right? So I can do that dynamically. You can do a lot of custom stuff with JUnit Jupiter that would be very difficult or impossible to do with JUnit 4. So this code's online if you want to check it out later. Okay. So for the test kit, as I mentioned before, if you want to test your own test engine or your own extension, so maybe I'd like to test that extension that I just wrote. This is an example for that, but I could make sure that when I run those tests, I could see that the outer one has a failure, and then the second one that has this new annotation, that they all just got skipped. I could actually write tests that test the test or test the extension. So here we have engine test kit. Right there, yeah, and then we can pick an engine. So here we're saying by the name, all engines have a unique ID. So JUnit Jupiter is the JUnit Jupiter test engine. And then we have various selectors. You can select things like classes, individual methods, packages, and stuff like that. So I'm saying select this one test class, execute it, filter out all the other events, just give me the test events, and then I want to assert the statistics on those test methods that were executed. And I could say in this test class, if you went and looked at it, one of the tests was skipped, 3 of them started, 1 succeeded, 1 was aborted, and 1 failed. So that's how you can test your extensions or your own test engines. So next up, what's new in JUnit 5.5 more recently released in the past month? We have support for global timeouts, preemptive timeouts, and an timeout annotation. I'm not going to go in detail on the global ones, but you can actually configure with several different properties in the JUnit-platform properties file in the root of your class path. You can specify timeouts for various different things, various different types of methods, or you can put @timeout like directly on a method. @enabled if and disabled if you knew those before, those were for scripting purposes. Like JavaScript, we have deprecated those, and they'll be removed in the next version. @value source for parameterized tests, that has new support for Boolean values. Also new empty value in the CSV support for parameterized tests. And I mentioned before this DisplayNameGenerator. In the latest release version, you can specify a default one for your entire test suite if you like to standardize across your tests, some kind of naming conventions. In addition, this Invocationinterceptor is also new, as I showed before. This new exception handler is new. And we also have something new if you're writing your own test engine. There's now configurable test discovery that you can base on, and for example, the new Spock test engine will be based on that, and JUnit Jupiter has been rewritten to be based on that as well. Also mentioned the Java 9 Jigsaw module descriptors, those are in there now as well. And I'll take a look at the timeout, see what that looks like. So here we have a test class. We got a timeout of 5 here, defaulting to seconds, right? And then we have a timeout with a value of 100, and then you can specify a time unit, milliseconds, etc. So if we just run this one, oops, no test file with JUnit 5. That sounds strange. Let's see. That was the setup, sorry. Yeah, so it's got the one test method. Right now it's not failing because it's not taking too long, but if we did sleep, what are we waiting, 500? Right, and throws declaration, sounds good to me. If we rerun that, we should see a failure. And maybe people can read that now. So timed out after 100 milliseconds, right? And we see that the time was actually 0.096 seconds, so we don't know how the math works out there, but we don't question, it's approximate, right? But so you can also have the timeout for the before method for the setup or for the after each method if you wanted to, you can do that. And again, if you don't want to put time all over the place, you want to have some kind of global timeout of all of our tests should execute within at least 2 seconds by default, then you could have a global timeout in a properties file, and that would be applied. Invocationinterceptor. Okay. Where's that one? Swing EDT. Yeah, so here we have an example of this new invocation interceptor API. As I was mentioning, there are lots of different things you could implement there. So you've got before test class, before all method, before each, et cetera, et cetera. In this case, we're just implementing the before test class. Actually, we're implementing the intercept test method for this one. So we get access to the invocation that we can call proceed on. And here we're saying use the swing utilities, invoke and wait, whatever the actual test method is. So this line would be the actual test method, right? When you say proceed, if you know anything like AspectJ, AOP programming, you can always say proceed and invoke the target thing. So this is like your target method. So it's going to invoke the test method within this event dispatch thread. And then at the end, we're going to track exceptions and then rethrow them if we need to. So that's one thing you can do with that new interceptor API. And the long one, bind exception handler. So this is one that I did for Spring, within Spring's test suite itself. So we have this abstract MBean server tests, and they all use the same port, which is right, bad idea for integration tests. And sometimes they pass, sometimes they fail, and it's really annoying when they fail on the CI server. We actually have an issue open to address that and make more of them pass regularly. But instead of having the build fail so often, what I did was I just came up with this extension here, bind exception handler, and what it does is it implements these 2 exception handler types, the test exception handler and the lifecycle one as well. Let's see, can make you see a little better now. So for each of those, I just implement them and I have a custom handle bind exception given the exception that was thrown. And if it's an instance of this bind exception, which means that we couldn't connect our MBean server, then I do a little trick. I throw a test aborted exception that's supported by JUnit Jupiter, which will abort the test mid-flight and report it as aborted or skipped. So we have that in place. So yes. Try to rerun it. So there are extensions out there that try to do that, and we might add some support later. You could try to rerun it. Yes, this was just a quick and dirty hack. I'm not saying you should do exactly this. I'm showing you that you can have exception handling on multiple levels and react based on that. Okay. So what's coming? So that's what we've got to date and coming up. In 5.6, so we're working on JUnit 5.6 right now. Those 2 script-based annotations for enabled if and disabled if, those are already gone actually. We have multi-character limiters for CSV source and file source, some support for custom null values in those as well. Improved documentation for using comments in those. And for the enum source, for your parameterized tests, you no longer have to declare the type. It can be auto-detected from the single parameter type in your method's argument list. In addition to these, so previously we had this @enabled on OS, and, @enabled on JRE and @enabled or disabled on JRE, and now we're adding support for ranges. So you can say this test should run on like JDK 8 to 10, and this one should be disabled on maybe I don't know 13 and higher or something like that. So we're adding that. At timeout is always applied currently, but we're going to add support in to have it automatically disabled if you launched the JVM in debug mode. Because it doesn't usually make sense to have a timeout when you're trying to step through the debugger and then the test fails while you're reading variables. So also support for selecting individual test methods and inherited nested classes. A new interface extension API for test instance pre-destroy callback. So when the test instance is basically being thrown away, you have something to do to callback to clean up if you need to. That's a counterpart to the existing test instance post-processor. And if you're writing your own parameter resolvers based on a type instead of based on an annotation for the parameters, there's just a new base class that makes that simpler. That's a generic adapter for the API based on a concrete type, this parameterized type here. And in terms of ordering the register extension fields, as I mentioned before, you can do that with @order, but we were using max integer.max value as the boundary on that, and we're going to change that so that you have more flexibility and be able to put things first or last in the list there. And we actually have significant performance improvements for the vintage test engine if you're using things like JUnit 3 suites and Scala tests and some other stuff. Running that on the vintage engine is going to run a lot better in the next version. So on the horizon, beyond 5.6, our backlog basically, we have parameterized tests now, but those parameterized test methods. And in JUnit 4, you always had parameterized test classes because you had this parameterized runner. And it was just a design decision to do it the test method way, very flexible. We have learned from the community that it's actually nice to be able to do it at the class level as well. So we're going to be adding that in addition to the method level. Some people would like to be able to run tests using custom class loader. We don't have support yet for that. And we also don't really have support for test suites, right? Like with JUnit 4, you had the suite runner. You could do suites. JUnit 3 had suites. In JUnit Jupiter, we don't have built-in support for suites. We do have a JUnit platform runner you might have seen, but that runs on JUnit 4 and doesn't really have the nice reporting capabilities, so it's more of a hack, and we'd like to get something first class in for that. Scenario tests is also something we're looking into. So you might have several tests or one use case, right, that's comprised of multiple steps, and you want to go step A, B, C, D, and go with them in order. And if maybe step B fails, you don't need to do the rest. You could report them as skipped or all failed or something like that. So we're going to add in support for that. Actually, the building blocks for that are already in place. So we have this test watcher, right, that I showed you. We have the execution condition. It's somewhat simpler to that use case that I implemented for somebody where I said, don't run this test class if there were failures before. You could do that, and you could also combine it with the method orderer, right? So you could order the steps, and you could track the things that failed and passed, and then you could conditionally not execute the rest. So the building blocks are actually already there, and that's one of our goals actually with JUnit Jupiter is to have building blocks to allow people to build their own unique features in, not just limited to the framework itself, but you can build your own. So it's very nice. Programmatic extension management. So right now we have that kind of declarative way with the annotations. We might add some way to do it programmatically, so you could order the extensions based on some kind of logic. And in terms of the reporting format, I showed you the nice layouts with these nested tests and these custom display names in the IDE. That's awesome. But unfortunately, all of the build tools and they currently generate the old school XML format for JUnit 4, right? And it doesn't know anything about the hierarchies. It doesn't know anything about nested test classes. It doesn't know anything about custom names. So you get these kind of ugly old school reports. And we need to, we're working on coming up with a new format for that. But it's probably going to take, I don't know, years for the entire ecosystem to adapt. So we'll probably have both in parallel for a while, right? Because then all of our CI servers are going to have to know which format to support. But it'll be better for all of us eventually. So now on to Spring and JUnit Jupiter. So for Spring support, we've had support fully integrated since Spring Framework 5.0. And that supports all of the core integration testing features you already know from the Spring Test Context Framework. But it adds some additional ones. So it adds support for test constructor and method injection with Spring's @Autowired, @Qualifier, and @Value. And it also adds conditional text execution based on spell expressions. Yes? Yes. This is the question is, do you have the entire application context? So with the Spring Test Context Framework, if you're not familiar with that, that's a way to launch your application, Spring Application Context, get it loaded for your test, and you can inject beans from that into your test. And that's worked since 2007. So quite a while, but that was always with the kind of field injection or setter injection, and now you can have constructor injection, which is the new feature here, and method injection into your lifecycle methods like at before each, or into a test method, etc. Conditional test execution, you can do things with a spell expression. You can even do it based on beans in the application context if you wish to do that. So decide to run a test if a bean is present in the application context. That's possible. We also have some convenience annotations. I'll show those in a second. Some people, hopefully, who's on Spring 4, 3? Anyone? Few people, 2 people? All right, so there are some people out there that for some reason in their projects can't migrate to Spring 5 or higher. Hopefully you're on Spring 5.2 now. But if you can't and you want to run new JUnit Jupiter tests with the Spring support, that does work with Spring Framework 4.3. If you go to my GitHub repo, actually the original support that I wrote for Spring, I wrote it against 4.3, and then I moved it all to 5.0. So this is not officially supported, but there are some people who use that out of necessity if they want to use JUnit Jupiter. So how do you configure it? There's a Spring extension, which implements several of these JUnit Jupiter APIs, I think about 8 of them or so. And the way you register that in JUnit Jupiter is @extend with Spring extension.class. And then in core Spring, we have Spring JUnit config, and that combines Spring's testing at context configuration and the registration to Spring extension, just simplifying things. And if you're using creating a web app, you can use the Spring JUnit web config, and that's just another level of abstraction combining the previous one plus the web app configuration to make sure you get a web application context. And again, we have these @enabled_if and @disabled_if annotations. Same names as the one from JUnit Jupiter, sorry for the confusion, but in Spring they're based on spell expressions, so Spring expression language expressions. Now, I assume many people know, may or may not know, since Spring Framework 4.3, it's no longer required to have @autowire declared on a constructor and a component. If you have a single constructor, Spring will just pick that and autowire that automatically. Now in Spring's JUnit Jupiter test support, you have to have @autowired either on individual parameters or on the constructor itself. And some people have asked to not be required to do that. So as of Spring Framework 5.2, just released, we have a new, well, this is default mode, and you can override that default mode. One thing you can do is set the spring.test.constructor.autowire mode to all, which means please automatically autowire all the parameters for my test constructor. If you want to change that, you can set that via JVM system property or the Spring properties mechanism. If you're familiar with that, spring.properties in the class path. Another option, if you want to change it on a per class basis, you can use this new @test_constructor annotation, and then just set the autowire mode to all or annotated. So by default, it's going to be annotated, which means you have to put the autowired annotation. But if you say you want to get all of them automatically, then you can switch it to all. So that works nicely. For example, with some people writing Kotlin-based tests, they like to combine this feature, this test constructor autowiring all, and they like to combine that with the test instance per class configuration option from JUnit Jupiter. So they get nice succinct test classes with data contracts and autowiring constructors and things like that. So this one, I didn't bother to actually create into a slide. This is just a screenshot. But I recommend, if you're interested to know what's new in Spring Framework 5.2 in general, go to the What's New in Spring Framework 5.x wiki page. And for the 5.2 testing support, you can just go to the testing section. And this shows you more things that you can do with Spring Framework 5.2, in addition to some of the things I mentioned here. So who uses Spring Boot? About 80%. Okay. Who's tried out Spring Boot 2.2? RC few. Okay. Right. So I say this here for Spring Boot 2.2, and this actually works with Spring Boot 2.1 as well. You can use JUnit Jupiter to write your tests instead of JUnit 4. And here I have an example with some custom config. So I mentioned you can have meta annotations, or you have meta annotation support from Spring and from JUnit, and we can combine that. So sometimes what I like to do for my projects is come up with my own little mini annotation-based DSL for things that I'm testing. So I want to take Spring Boot test support and the auto configuration of MockMvc and extend it with Spring extension or some other things, and I can kind of put that all together. So here we have an example. Make sure that the retention is runtime, otherwise it gets lost, right? And here I've got Spring Boot tests, auto configure MVC, and I've got @transactional from Spring. Now, I did have the @extend with Spring extension, but that was before the Spring Boot team decided to automatically annotate Spring Boot tests. So Spring Boot test, if you look at the source code for that, it is meta annotated with exactly this, @extend with Spring extension. And actually all of the testing annotations in Spring Boot 2.2, I think 2.1 and higher, are meta-annotated with adding with Spring extension. So if you use like the MVC support or the data support or the basic Spring Boot test support, those things are already annotated with this, so you can just leave off this line and just start coding with Spring support and JUnit Jupiter. So this is my custom annotation, right, at interface, and then I can use that anywhere I want this combination of features. So this is support from JUnit Jupiter, Spring Boot, and Spring, all these annotations combined into my own custom annotation. And I've got an example here using that, plus method level dependency injection for a test method and accessing the MockMvc instance that's created by Spring Boot. So this is my test class, Spring Vince web test. I've got a test method here, Autowiring in the MockMvc that's created by Spring Boot for me. I can use it locally if I want to. This could be a good practice, could be a worse practice. If you have this in every test method in your class, I'd say it's a worse practice, don't do that. But you might want to inject it to it before each method, or you might just want to inject it to a field, it's up to you. But the point is you have new options now, or even you could have this auto-wired into the constructor for the test class if you wanted to have some immutable fields, stuff like that. So then you can just use the MockMvc just like normal. So this is one thing that's become a popular question in various circles and on Stack Overflow. How do I upgrade the version of JUnit 5 used when I'm using Spring Boot? It's actually not any different from the way you would upgrade any other versions that you're using, any other dependencies, but a lot of people just don't realize how they can do that. So you can read the thread on Stack Overflow if you like, but I'll show you here to save you some time. So in Gradle, you want to add some extra properties, and you have to look in the Spring Boot parent POM or dependencies, whichever that thing's called. You know, there's a big list of all the dependencies on all the versions managed by Spring Boot, and this is the exact name you have to know for JUnit Jupiter. It's called JUnit-Jupiter.version, and in Gradle you could set it to this 552. If we have a new one, 553 or something like that, and you want to upgrade before Spring Boot does, that's how you can do it. And in Maven, it's also similar, exact same name, JUnit-Jupiter.version, setting it to 552 or whatever. So if you don't do that, what happens? If you try to upgrade individual versions, maybe just the JUnit Jupiter API or just the engine, then you're going to end up having maybe some class not found exception or some strange stuff, right? Because you have various competing dependencies, because Spring Boot's the BOM management, dependency management, it's going to override some versions, but not the versions you explicitly set. So you need to do it the proper Spring Boot way. So getting involved, if you'd like to, you can participate on GitHub, right? You can report issues, suggest new features, participate in discussions, provide some of your own insight. You can also help answer questions on Stack Overflow or on our Gitter channel. And if you'd like to, you can support the JUnit team with donations via Steady HQ. So, in closing, oops. Oops, sorry about that. Small table. So I've got some links to resources here if you want to get involved. Talk too fast. Demos used, got links here. So JUnit 5 demo that I showed you here, also from the documentation, from the reference manual for JUnit 5. You can check that out as well. Some of the examples from there. One of the examples was from Spring's testing suite. You can check that out as well. And now, so two options. We've got a bit more time. It's a long session. If you have questions, you can ask questions. That's cool. If you want me to show you something, like actually live code something, I'm up for that. But maybe do questions first, and then I think we got like 10 minutes or so. Yeah, here first.
Is there any out-of-the-box support for outputting code coverage reports, so you might not need like code those, something like that?
So the question is there any built-in support for code coverage reports? No, there's nothing built in. You have to do it the way you used to do it. Yeah, yeah. Some things have changed a bit, but you can Google and find other examples how people got it to work with JUnit Jupiter. Yes.
TestNG, there's a lot of features that used to have that JUnit didn't have. Is there anything now that you think that JUnit doesn't have?
So the question is, comparison, it's always a comparison of TestNG and JUnit Jupiter. There are presentations on the internet other people have done who are more knowledgeable. So yeah, TestNG has always had some features that JUnit didn't have, like parallel test execution and groups and kind of interdependencies and stuff like that. I didn't point out here, we do have parallel test execution since last year, since 5.3, yeah. So you can configure that. We have that. In terms of the dependencies, we don't have built-in support for that yet, but there's a way to do it, and there's a pull request open. I'm not sure if we're going to add it, but it is possible to do that with this test watcher and these conditions. So you can say and a method order. It's similar to the scenario tests I described, so that would be similar. TestNG also has groups, right? And we have tags. So it's not quite the same, but it's somewhat comparable. And there are a few other things that TestNG does more for integration testing for some parallel stuff and configuring all the threads and stuff like that. We don't have support for it in JUnit Jupiter. But in general, JUnit Jupiter has more features than TestNG does. TestNG has a few that are geared more at integration testing. Anyone else? Yes.
The SpringOne 1, I used to use DBWriter and SpringTest DBUnit. Now in SpringOne 2, DBUnit 5, SpringTest DBUnit doesn't work. Well, it doesn't work, but I'd like to move up. Do you have any recommendations?
DBUnit, you said, yeah? Yeah. So the question was, previously with Spring testing support and Spring Boot, you used the DBUnit test execution listener, which was written by Phil Webb. Trivia, in case no one knows that. Yeah, that's not supported anymore. There's a wiki page we have. It's the same wiki page that I mentioned in the slides, the third-party extensions. So it's not only engines that are listed there, there are also extensions listed there. And there's one, I believe it's called Rider, DB Rider, something like that. And it's a JUnit Jupiter extension for something like DBUnit or.
Even immediately, I encountered a lot of issues with that. After the recommendations.
Oh, you tried it? Oh, no, I don't have any other recommendations at the moment.
Anybody else does another year?
Any other questions? Yes?
Where did the swing utils in the code snippet there? You said it has swing utils invoke later or something?
Yeah, that's not the swing utils, that's the core Java. Yeah. Anyone else? Yes.
This might be the wrong place to ask this, but have there already been extensions built for support for other DI frameworks like DAG?
So the question is, are there already other extensions out there that support different dependency injection frameworks? There's one for Weld, CDI, and that's listed on that page I mentioned, the third-party extensions. As for other ones, I'm not aware, but there certainly could be. Sorry, back there. Can I go back? Yes. To where? That one. Okay. Yes.
So how does the parallel testing work with nested tests?
So it's going to be some of the things configurable. It won't do the parent ones and the sub ones. Yeah, at the same time, it'll do them separately. And there's also a way to, you can set up, there's an resource annotation, and you can also specify things. You can give names to things where you can have read-write locks, so you can control when things can potentially be run in parallel or not. Yeah, and there's some examples in the user guide for that. Yes? Sorry, Andy? So the question is about exception testing with JUnit 4 and accessing the exception. So before each and after each, that was kind of a sub-question, when are they applied? Before each and after each are applied before and after each individual test method, or invocation of a repeated test or of a parameterized test. But they don't have access to the exception, right, that was thrown from the test. If you want to access the exception that was thrown from the test, you have to implement one of those exception handlers. that I wrote. So there's the test execution exception handler that gives you access to the actual exception if you wanted that. But what people do these days, we don't really like to, as a community so much, do it the way we did it before. We don't like to have the @test expected exception or this expected exception rule like in JUnit 4, because people can make mistakes. So we have the new assert throws assertion, right? So you actually, the exception is caught, your Lambda expression is executed, your own code. And then you get the exception and you can expect it there. And other assertion frameworks do that as well, like AssertJ and other things, yes? Yes, so what happens, there's a try-catch block behind the scenes. So once you've caught the exception, then the test continues to execute, because that's what you're testing. You're testing that you expect the exception, right? And then you want to just verify maybe the message or the cause or something like that, the root cause. And then you can have additional assertions in that method if you want, or the method just continues to execute. Mm-hmm. Anyone else? No? Anyone want to see anything? I think we got a few minutes. Or we could just call it a day and go off to lunch. Or the next talks. Okay, no questions? Then thank you for coming.